Okay, we continue. So let's now just go into the system and have a look what's there and how it sounds and how it works and how you can patch it up together and spend the rest of our 2 days only doing that, making sounds. So I already said that basically we have 3 functions. We have generators, well, 3 classes of functions. We have, what is sort of traditionally used treatments. And we have mixing as a function. That's basically sort of what you use. Now for generators, that basically means that these are devices that are able to produce waveforms. That can be sound waves that you can actually hear in the audio range, but those can also be waveforms that have lower pitches. So then they are called low frequency oscillators. They can also be supersonic generators, although they are not really very useful with when you make sounds because you cannot hear them. So basically we have 2 of them. We have audio oscillators, and we have sort of, let's say, low frequency LF oscillators. Now, when it is about oscillators, then there is sort of like a traditional idea about sound synthesizers that is basically from the early 60s of the last century, that also was sort of giving you the idea of modules. That is you sort of separate different kind of things in the sounds in separate little devices, so you can sort of manipulate them separately. And so if you a sound, a singular sound, basically has 3 important properties, and that is it has a pitch, and it has an amplitude, a loudness, and it has a timbre. And the original idea of this early 60s was that if you put something that produces the pitch into one module or device, something that sort of manipulates and sets the volume in another, and one that sort of manipulates the timbre in a third one, you would have a sort of a system with which you could make any sound. This idea is also basically based on a model, a physical model, which I call the exciter-resonator model, which you find in many musical instruments. For instance, if you just take let's say we take an acoustic guitar. If you have an acoustic guitar, you have a string. Now, if you only have the string and you tighten it and you pluck it, it will give you a pitch, but it will produce hardly any volume at all. But the moment when you attach it to a resonant body, then suddenly you gain a lot of volume. So basically what you think about is that you think in terms of energy. You basically put energy into the string by plucking it, but if that energy cannot go somewhere, basically Helmholtz has proven that it will all be transformed into heat and not into much audible sound. So where it stays, the sound is heat. But then if you attach it to a resonant body and you make a mechanism that basically the vibration of the string can make the body of the guitar vibrate as well, then basically the energy stays in that resonant body and builds up, and that way you get your volume. So that idea is present in the early Bob Moog synthesizers, because there you actually have an oscillator which basically produces the pitch, but actually it produces the energy. And this oscillator has a specific kind of property that we will look at later. And this signal coming from this oscillator is fed into a filter, but it is a resonant filter, meaning that it can sort of build up a resonance in the filter and in that way sort of shape the timbre of this sound that comes from this oscillator, which is a very neutral sound by default. And then you have some more manipulations to things. So while a sound is made of, basically defined by a pitch and a volume and the timbre, it's better to say that a sound is defined by how pitch, volume and timbre change over time. So what you want to do is change these three parameters over time. And the process of doing so is called modulation. And because you're constantly doing that, you're constantly modulating the sound. So there is a bit of, well, you can philosophize a bit about this idea with this oscillator, because an oscillator does not only produce the pitch, it also produces a basic volume, and it also has a basic timbre. So it already has the three things. So it's not that you can completely physically separate these three. You can never do that. They are already present in the oscillator. So basically the oscillator is the generator, and whatever comes next are treatments that you do to the sound. And by modulating both the oscillator and the treatments, that's basically how you synthesize the sounds by electronic means.